In the part A of the question, we are supposed to find the binomial expansion of cos theta plus I sin theta to the power of 5. Before we do that, let's write down the basic binomial expression. So here we go. If we have a plus b whole to the power n, this is how the binomial expansion looks like. So nc0, a to the power n, b0, this will be the first term. And basically any general term will be ncra to the power n minus r, b to the power r. This is the general term. So the value of r is equal to 0 if it's the first term. The value of r for the second term is 1 and so on. In the part A, we are supposed to expand cos theta plus I sin theta whole to the power of 5, which means let's say A is cos theta and B is I sin theta, and the value of n is equal to 5. So the first term will be nc0. So that will be 5c0 cos theta to the power of 5 multiplied by I sin theta to the power of 0. Similarly, the second term will be 5c1 cos theta to the power of 4 multiplied by I sin theta whole to the power of 1. Similarly, if we keep doing this to find out the overall expansion, we will get this. In this, you can see there are a total of 6 terms. So this is the overall expansion of cos theta plus I sin theta whole to the power 5. The first term, cos theta to the power 5, is real. So let's keep it as it is. The second term has an I in it. So that's the imaginary part. In the second term, we have an I squared. The value of I squared is -1. So the third term is also a real part. Similarly, I cube is -I. So this is an imaginary part. The fifth term has an I to the power 4. I to the power 4 is 1, which means this term is also a real part of this complex number. And I to the power 5 is I. Now let's try to simplify this, because in the part A, we are supposed to find the answer in the form A plus BI. So let's simplify. If we club all the real parts together and all the imaginary parts together, we will get this. Let's see. Cos theta to the power 5 is the first term. And then we have this 5c2, which is 10. I square is -1. So we'll get a -10 cos cube theta sine square theta. That's also a real part. Similarly, 5c4, I4, I to the power 4 is 1 and 5c4 is 5. So that's the last real part. So the three terms combined will form the real part of the complex number. Now, in the remaining terms, we will take I as common. So in the second term, we have 5c1, which is a 5, cos 4 theta, sine theta. Then in this term over here, 5c3 is equal to 10 and I cube is -I. So we will write -10 cos square theta sine cube theta. And finally, in the last term, I to the power 5 is I. So the final expression will be sine 5 to the power theta. Remember, we have taken I as common among all of these terms. So now the entire expansion can be written as A plus IB, where A stands for the entire expression in the first bracket and B is all the expressions in the second bracket. And that's what we were supposed to do in the part A. We were supposed to find A and B expressed in terms of sine theta and cos theta. Now moving to the part B, we take the answer which we found in part A, and using the De Moivre's theorem, we are supposed to prove this expression for sine 5 theta. So the expression which we got in part A was this. We had expanded the cos theta plus I sine theta to the power 5 in A plus IB form. Now, according to the De Moivre's theorem, the left-hand side of this expression can be written as cos theta plus 5 times I sine theta. So let's write cos theta, which is the real part, plus I times 5 sine theta. This will be equal to the entire expression on the right-hand side. Now, all we need to do is just compare the imaginary parts. On the left-hand side, the expression in front of I is a 5 sine theta. On the right-hand side, this entire bracket is the imaginary part. So let's equate the 5 sine theta with this bracket. So we will get 5 sine theta, which is coming from the left-hand side. From the right-hand side, we get 5 cos 4 theta sine theta minus 10 cos square theta sine cube theta plus sine 5 theta. Let's go back to the part B. We were supposed to find out sine 5 theta, and look on the right hand side, all the expressions are in terms of sine, which means we need to eliminate the cos terms from our expression. Now we already know the basic trigonometric identity sine squared theta plus cos squared theta is equal to 1, which means if we make cos squared theta as the subject, we will get 1 minus sine squared theta. Now let's use this to simplify our expression. In the first term, we have cos 4 theta. Cos 4 theta can be written as cos squared theta squared, which is 5 times cos squared theta, and we square it one more time. Sine theta minus 10 cos squared theta sine cube theta, and at the end we have a sine 5 theta. Now let's replace all the cos squared theta with 1 minus sine squared theta. So in this expression, we will get 5 times cos squared theta is 1 minus sine squared theta whole to the power 2 multiplied by sine theta minus 10. Cos squared theta again can be written as 1 minus sine squared theta multiplied by sine cube theta. And at the end, we have a sine 5 theta. Now over here, this can be expanded by a minus b whole squared formula, which is a square plus b square minus 2ab. So in the bracket, we will write 1 plus sine 4 theta minus 2 sine square theta. In front of the bracket, we have a sine theta. In the middle term, let's multiply the 10 and sine cube theta with this bracket. So eventually, we will get minus 10 sine cube theta plus 10 sine 5 theta, and at the end we have a sine 5 theta. Let's simplify the expression further because here we have a 5 and a sine theta. Let's multiply 5 sine theta with this entire bracket. So we will get 5 sine theta plus 5 sine 5 theta minus 10 times sine cube theta, and the remaining expressions let's write as it is. 10 sine cube theta plus 10 sine 5 theta plus sine 5 theta. Now let's simplify to get the overall answer. We have a 5 sine theta that cannot be clubbed with anything, so we write it as it is. Now we have sine 5 theta with a 5, and over here we have 10 sine 5 theta, and at the end we have a sine 5 theta. So if we add all the three terms, we will get 16 sine 5 theta. So it's basically like taking sine 5 theta as common. So we'll get a 5 plus 10 plus 1, which gets us a 16. The remaining two terms has a sine cube theta in them. So minus 10 will become minus 20. So the last expression comes out as negative 20 sine cube theta. And this is what we were supposed to prove. We had to find sine 5 theta all in terms of sine. So we have a 16 sine 5 theta minus 20 sine cube theta plus 5 sine theta, which we got here. And that's how we solve the part B of this question.